Hello! In this video, I will teach you about file name substitution. Specifically, I will show you how to use basic wildcard meta characters to build ambiguous file names, which refer to multiple files and directories at once in the Linux shell. Here are the contents of my current directory, which I will refer to in this video. Regular files are shown in white, while directory names are blue. Let me start by reviewing some of the terminology I will use throughout the video. With the exception of the root directory, each file and directory on a Linux file system has a name. While regular files serve a different purpose than directory files, the naming follows the same rules. I like to use the generic term file name, which refers to both regular file and directory names. Sometimes several file names are put together to form a path or path name, where file names are separated by forward slashes, allowing us to access files and directories outside of the present working directory. Commands which operate on file names or path names receive them as parameters, provided as a space-separated list. For example, if I would like to duplicate customer 0 and customer 2 files into the tmp directory, I can do it using the cp command. In this case, the cp command received three parameters, sometimes called arguments, two source file names, and one destination directory. The copy command, or most of the other common commands for that matter, can handle an arbitrary number of source file names. Typing them by hand would be rather tedious if there were more than just a couple of them. The shell has a feature where wildcard meta characters can be used in an ambiguous file name to refer to multiple file names at once. The process of defining these wildcard patterns and using them to match existing file names is called globbing, while an ambiguous file name is generically called a glob. I use the term wildcard expressions, ambiguous file names, and globs interchangeably. The first file name matching meta character is the question mark, which matches any single character. In a simple scenario, we can combine it with a literal match. For example, here's how I would copy files with names that start with customer, followed by exactly one character, into the process directory. I use the -v verbose option with the cp command so you can see which files were matched and ultimately copied. But you can always use the ls command to verify the command outcome. In this case, the shell matched multiple file names in my present working directory, where the question mark wildcard matched digits in the names such as 0 through 9 and lowercase letter s. Wildcard matching does not distinguish between regular files and directories. In this case, there were 9 regular files and 1 directory matched, but only the regular files were copied. The customer's directory was not copied, as the cp command did not have the -r recursive option, which is required to copy directories. There is a way to distinguish between regular files and directories in the file name substitution, but this requires a bit more knowledge on your end, so I will explain that in the next video. While the substitution process is transparent to us, we can actually see what the above command looks like after the shell performs the file name substitution if we prefix the entire command line with echo, the shell's print command. Using the echo command is a common method to test or preview a command without actually running it, which gives us a chance to fix potential problems and diminish the risk of accidental data loss if we use globbing. You can certainly appreciate that I did not have to type such long list of files, but only the short glob. File name substitution is a feature of the shell, and for that reason it will work with any command. As long as a match is possible, the command does not see the wildcard expression, only the files that were matched to it. We can use multiple question mark wildcards in the same glob. For example, now I will move all files named customer followed by 2 characters. This time 7 regular files were matched, The first question mark matched the digits 0, 1, 2, and 6, while the second question mark matched letters X, Y, and Z, and the digit 2. The ability to match any character using the question mark is very handy, but sometimes we want to be more specific and limit the matches to a narrower group of specific characters. For that, we have the square bracket character class. Just like the question mark, the square bracket class will match a single character, but this time out of the list provided within the square brackets. We can put as many characters inside the square brackets as needed, either on their own or as a dash-separated ranges of consecutive digits or letters of the alphabet. For example, now I will copy the following files into the temp directory: customer1, customer3, as well as files named consecutively customer6 through customer9. I have seen some internet tutorials on this topic which separate the square bracket items with commas. Unless you are matching a literal comma, in which case you would have only one inside the square brackets, separating list items with commas would be incorrect. This wildcard expression matched 5 files. An ambiguous file name is like a wish list, and the shell would do its best to satisfy it, but in some cases there may not even be one match. For example, the following pattern will not have any matches. In this case, the shell looked for file names starting with customer, followed by a digit, followed by .txt. None of the files in my present directory satisfy such requirements. As no file names matched, the shell did not make any substitution, and the cp command received the ambiguous file name untouched, including the square brackets. This is an important finding. Ambiguous file names are only substituted if possible. Otherwise, the shell passes on the wildcard expression unchanged to the command. If the substitution does not happen, the command will try to use the ambiguous file name literally, which can become a problem. In this case, trying to copy a file actually named customer square bracket 0-9 square bracket .txt, which ultimately resulted in the copy command producing a no such file error message. This time, the failed match did not cause any real problem, as no files were created, changed, or lost in the process. The copy command informed me that there was a problem, and I have a chance to fix the pattern and run the command again. In other cases, a failed substitution may not result in a visible error message, possibly silently making unwanted changes to the file system. Let's say I would like to update the date stamps of files with names that start with customer, following by one more character, but mistype customer. There were no matching file names, so the glob was not substituted. The touch command worked with what was provided literally, making a file actually named customer ? Unless I checked using the ls command, I would not even know that this has happened. The date stamp was not updated for the files I wanted to update, and now I have an extra file with a misspelled name. I need to delete it. The unwanted file has a special character in it, the question mark, so it needs to be quoted using the backslash. I explained in detail in my previous video how special characters in file names can cause problems and how to use quoting to avoid them. The shell has a number of environmental settings which control the wildcard substitution process. One of the settings which I like to use is the fail glob. Here's how the fail glob environment setting is enabled. This setting, when enabled, instructs the shell to produce an error message when there is no match to an ambiguous file name, and the actual command will never be run. Let me rerun the previous command so you can see how the shell behaves now. This time, I got a no match error from the shell. the touch command was never run, and therefore no unwanted file was created. The shop command, shopt, stands for shell option, and it is used to modify the default behavior of the shell. Environmental settings such as this one stay in effect until they are unset or the terminal is closed. You can make them permanent by adding the set command to the hidden bashrc shell configuration file. You can edit the .bashrc file using any text editor, for example Nano. I suggest placing the command just before or after any existing shopt commands. You can also make a comment about it by adding a line that starts with a hash or pound sign before it, explaining what the setting does. If you have not used Nano before, you press Ctrl X when you are done with the file changes. Confirm the changes by pressing Y and Enter to exit the editor. Sometimes it may be easier to specify which characters we do not want to match. This is accomplished by providing the exclamation mark at the beginning of the list inside the square brackets, which in this context means not. This exclusion affects all characters listed after the exclamation mark inside the square brackets. Let's say I would like to remove all customer files except customer1 from the temp directory. I can use the square brackets for that with the exclamation mark exclusion. 6 customer files were removed with customer1 file remaining. Multiple sets of square brackets can be used together, each matching single characters out of the characters listed within each of them. For example, the following will duplicate files from the process directory into my current directory with names followed by 0 or 2, but not followed by Y. In this case, 3 files were matched. Notably, files customer 0Y and customer 2Y did not match and they were not copied. While the first square bracket matched them partially, the Y at the end of the names ruled them out. Whether you use a single set of square brackets or multiples, what is not immediately obvious to beginners is that we need a minimum of 2 characters inside the square bracket group. Beginners often do not realize that and make wildcard expressions such as this one. This wildcard expression works fine and produces valid matches, as I see a matched subset of files inside my process directory, but the second set of square brackets does not do anything, as it can only match a lowercase y. In this case, a literal match of lowercase y should be used. Same results, but a simpler command. Simpler is better. Different wildcards can be used in the same glob. For example, now I will copy all files named customer, followed by either 1 or 2, followed by one more character into temp. This time 3 files were matched and copied where the question mark matched letters X and Y. The question mark is not in square brackets here. If I did that, the square brackets would act as quotes, turning off the wildcard property of the question mark, and the question mark would be matched literally in such case. There is often a need to wildcard match more than just one character. For that, we use the asterisk, which will match multiples of any characters. For example, I have several directories with names starting with invoices in my present working directory. Here is how I would move all of them into the process directory. In this case, it was sufficient to start with a literal match of lowercase letter I and then add the asterisk wildcard, as there were no other file names starting with lowercase I in my current directory. Such expression reads as file names that start with lowercase letter I, possibly followed by more characters. If there was a file simply named lowercase I, it would be matched here as well. We can combine the asterisk wildcard with other wildcards in the same glob. For example, here is how I would copy file names into temp directory, starting with C and ending with a digit. The matches include the C5 file, which has no characters between C and 5. Those non-existing characters were matched by the asterisk wildcard. The asterisk wildcard can match nothing when combined with literal matches or other wildcards. That's it for the basics of file name matching, but there is so much more. Go ahead and check out the more advanced video, but before you do, please hit the like button and subscribe. It takes only 2 seconds, it costs you nothing, but it lets me know that what I do makes a difference for you. Thanks for watching.